ToDoodle 28. Now we're talking about putting fractions together. We've done a little of this, but we're going to focus on it more. Here's our first problem. Chantel is making her friend Jasmine a beaded bracelet. Their favorite colors are teal and purple. And she's using a repeating pattern of 3 teal beads and then 2 purple beads. If she needs 45 little beads to fit around Jasmine's wrist, how many beads of each color will be in the bracelet? How do you find your answer? I'm going to pause the recording while we think about this. Okay, we have some little bead marks here. So this is the repeating pattern, 3 teal and 2 purple. And we figured out, yay, if we have 9 copies of that, counting by 5s, 5, 10, 15, 20, 9 times 5 is 45, and we're done. So that's what we have. How many beads of each color? 3 times 9, so 27 of teal. And then 2 times 9.
This meeting is being recorded.
So 18 of purple. Okay, what fraction of the pattern is teal? How many out of the total are teal? Tell me either number. You can tell me the teal part, or you can tell me the total part.
18. 9.
You were cutting out. I'm sorry. Start over.
Fraction of the pattern is teal is 27.
27. 27 teal. And what's the total?
Altogether, 45.
45. Yep. Everyone happy with that too?
Yes.
It's a little strange. I'm not sure which of these April just answered. The entire bracelet is here, 45 total. Of the pattern part, then it's, it's 3 teal out of 5 total for the pattern. But those are the same. It's just kind of how much of them I have. If you're thinking of unreducing fractions, then what's happening is we're saying times 9 on the top and times 9 on the bottom. 3 times 9 is 27. 5 times 9 is 45. So this is the same fraction. It's just a little different, whether you think of it as I'm only looking at one of the 9 pattern bits, or I'm looking at the whole bracelet once it's done. But the fraction that's teal is still the same. These fractions are equivalent. Questions about this page before we go on? Thumbs up, thumbs down.
I'm good, thank you.
Nope.
Oh, the cat. Okay. Fractions sometimes appear when we use tables of data. So Sophia asked some students at her school if they have their own cell phone. And unfortunately, her sister spilled some pasta sauce on her notes. We're missing some of those numbers. Can you help restore her notes? So in the 6th grade, there were 18 total. 13 said, no, I don't. So how many do have a phone?
5?
5. We want these to add up to 18. So this one has to be 5. Grade 7, I can't do that yet. Grade 8, 14 have a phone, 2 don't. So what's the total?
16.
16. Now we check the other direction. Yes, I have a phone in all the grades, 5 and 8 and 14. Does that total 27?
Yes.
Yes, hooray. Okay.
Mhm.
No, I don't. 13 and 2 and something is something. We are not really ready for that yet. How about the total? 18 and something and 16. That's 48. What's the something going to be? We need 48, then take away 18, and then take away 16 more. You can do that on a calculator.
14.
Okay, now we can do this one.
Six.
And then if we go this way, 13 and 6 and 2 makes
21.
so that's a great kind of test question. Tests love this kind of thing. Everyone okay with our setup? We haven't actually made any fractions yet.
Yeah.
So now which fraction of students in each grade have a cell phone? In grade 6, it's going to be something over 18. In grade 7, it's going to be something over 14. Everyone see why? Okay, tell me what to write for the rest of the numbers.
Well, grade 7 is half the.
It's almost half.
Same.
It's 8 out of the 14.
Yeah.
A little more than half.
Yeah.
Okay, 3 more numbers. 1, 2, 3. Tell me what to rate.
5 would be over 18.
3.
Fourteen over 16.
Perfect. Okay, everyone happy with this?
Yeah.
So very common kind of test
Yeah.
question. Here's a bunch of data on a table. See where the totals are. Pay attention to which parts they want. Are they looking for the ones that do have a phone or the ones that don't have a phone? Because they could have asked us either question. And then make your parts over whole. Okay, moving on. The great thing about the unit fractions, always having a 1 at the top, is that almost the same picture works for adding when we're combining or multiplying when we're taking a fraction of. But it's a little different. So here we go with action. Lights, camera, action. I'm going to start with a third. Everyone okay with my third?
Yeah.
Now I'm going to also shade in 1/2 more.
Mhm.
So Ruthie paid for a third of the pizza. April said, oh, I'll pay for half of the pizza. I'm more hungry. So she wants to shade in 3 boxes. So here she goes. Now, when she gets to this line, if she keeps going, she's going to double count that top left corner. Does that make sense?
Mhm.
But that's a part of the pizza that Ruthie's already paid for. So she's gonna shade her third of the box, her third box down there. Are we okay that this is also half of the things? 3 out of 6. So what's the amount that's shaded total? How many out of 6?
4.
Not 4. 1, 2, 3, 4,
5.
5.
2, 3. 5.
So a half and a third is 5/6. Now we're going to do the same thing for multiplying. Now we want half of 1/3. So here's a third. Whoops. Shading. Okay, so here's my third. And now I'm going to shade half of the third. It might be that I just shaded half of the box and saw where they overlapped. That's also one way to think of half of a third. So what is half of a third? That's just this one box, right?
Mhm.
So how much of the 6 is that? Don't think too hard. How many 6 are the half of the third?
2.
2? No, I only have 1
1.
6 boxes. Okay, stare at this a little bit. When adding, we had to avoid double counting the overlap. If we had tried to shade this one blue, we would have double counted this. But since we're combining, then we can't double count things. This was already counted. We need to combine it with new stuff. When we're multiplying, what's half of a third? Where the half and the third overlapped? The half and the third where they overlapped, that is the answer. It's not something we avoid. Everyone okay with that?
Mhm.
Replay this part of the video if you need, because it's a subtle thing. How about subtraction? After a party, there's half of a cake left over. Late at night, you sneak into the kitchen and eat an amount that's equal to a third of the original cake size. How much of the cake remains after your midnight snack? Tell me what to do or do it yourself. Can somebody eat a third of this cake?
I think I read into it so much. So it's asking if we ate 1/3 of the original cake size.
Yep. How many sixths would that be?
Would be 2 of them.
2 of them, right? Maybe you see that it's 2 of them because the way your brain likes to see it is 1, 2, 3. Or maybe the way your brain likes to see it is 1, 2, 3. But either way, a third is 2 of them. So we're going to eat 2 of them. Yum, 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 yum. How much of the cake is left over after our midnight snack? What fraction would I write?
1/6.
1/6. You got it. So we've just done 1/2, take away 1/3 equals 1/6, but it was easier to see with the picture than trying to write it like that. Okay, we're almost done, 2 minutes to spare. Another common situation with unit fractions is discussing time. Last weekend, Andrew went on an enjoyable hike for 2 1/3 hours. But this weekend, he was only able to hike 1.5 hours. How much longer did he hike the first weekend? So if you have time before Thursday, this could be an interesting homework one. It might help to draw on the clock. What does it look like to have half an hour? What does it look like on the clock to have 20 minutes, thirds of an hour? Does that make sense?
Truthfully, no.
Okay, well, we can do this next time if we need. Or you could torment your friends and loved ones.
I like the second idea first.
I'm going to stop the recording, and while we're thinking of homework, ask about who did homework since I saw you last.